Hello, and thank you for tuning into this week's episode of Bite-Sized Cybercrime, the podcast where we discuss cybercrimes and cybersecurity news. This week we'll be talking about what is believed to be the first ever case of a ransomware operation known as JadePuffer, conducted entirely by a large language model LLM agent, or you may know them as AI agents. JadePuffer used an autonomous AI agent for reconnaissance on the target, information gathering, stealing credentials, moving laterally within their environment once they had established a foothold, actually establishing persistence within that environment, so being able to remain there, escalating privileges, and encrypting data in the environment. And none of this involved any human intervention whatsoever. The AI agent was able to adapt to failures during the intrusion, kind of like how a human hacker would handle things that get in the way. I'm sure I don't need to tell you, hacking is not easy. It's incredibly hard, in fact. It's very difficult to do, and it's incredibly competitive. And things change all the time in the cybersecurity landscape, so obstacles are pretty much guaranteed. Whether it's certain ways networks are set up, permissions blocking you from doing things, fully patched software applications, multi-factor authentication, email phishing filters, network intrusion devices, firewalls, proxies, reverse proxies, encryption, endpoint detection and response. There's a lot of things that stand in a hacker's way, which is why they need to be really good at what they do in order to figure out ways around these things. The AI agent was able to do this in the same way that a human hacker does this all the time. The AI agent adapted in real time. They retried failed steps within these specific defined parameters. In one sequence, it went from a failed login to a working fix for that failure in 31 seconds, according to SysDig, a cloud security company that gives real-time insights to your cloud environment. So, how the heck did this work? JadePuffer initially gained access to their target by exploiting an unauthenticated remote code execution vulnerability in LangCode, which is an open-source framework used for building LLM, or agentic AI, apps. The vendor fixed this flaw on April 1st of 2025. It was likely targeted via an internet-exposed endpoint that was likely deployed with minimal hardening, but still contained cloud credentials and maybe even API keys. After the AI agent was able to execute code through that vulnerability, it then dumped Langflow's PostgreSQL database, collected host information, and searched for environment variables and sensitive files. It was able to retrieve credentials, and then enumerate an object store known as Minio. On the machine that hosted Langflow, JadePuffer was able to establish persistence by installing a cron job on the server. A cron job is basically an automated time-based task scheduler in Unix-like operating systems like Linux, macOS, and, well, Unix. This cron job was configured to beacon to the attacker's infrastructure every 30 minutes, reaching out to them to make sure that there was still a connection persistent. From that same Langflow instance, the attacker pivoted to a production MySQL server. There, the AI agent was able to use root credentials to hijack it. That MySQL server was running Alibaba's Nakos, which is naming and configuration services. And what's important to note is Nakos had multiple different vulnerabilities that it was targeted by, one of them being an authentication bypass vulnerability that creates rogue administrator accounts. So the AI agent was able to just basically create these random administrator accounts to have admin access and didn't need to authenticate in any other way. The AI agent was then able to deploy a ransomware payload. According to researchers, JadePuffer managed to encrypt 1,342 Nakos service configuration items before deleting the originals. This, of course, encrypted the MySQL data and put their target in a position where they had to either accept their loss of all of this data, or they had to pay up. The ransom note left on the machines claimed that data was encrypted using the AES-253 algorithm, although researchers believe that it's actually more likely to be AES-128-ECB, which is easier to crack. Not that it's, trivial or anything, but it is easier than AES-256 for sure. For context, ECB is notoriously insecure and should really just be used for testing purposes. In modern cryptography, there's methods that use initialization vectors and chaining to kind of randomize the patterns. ECB doesn't do this, so if you encrypt a certain text, the ciphertext will actually retain some of those original patterns, and you can kind of like reverse engineer it. In the context of cryptography, an initialization vector is a random value that is unique, used in cryptography alongside a secret key to encrypt that data, and it basically is there to ensure that identical plaintext inputs encrypt into completely different ciphertext outputs. So, in other words, if you encrypt the same message with this algorithm different times, it's going to be different even though it's the same message. This prevents people from identifying patterns or reusing certain intercepted messages. Chaining requires me to explain a couple other things, so just give me a second. I'm not an encryption expert, but I'll try to make it as easy as possible. So, ciphers mostly encrypt data in blocks in this case. Common block sizes are 64 bits or 128 bits in AES specifically. The data is split into these equal-sized blocks. If one of them is too short, they just pad it with more data. So, basically, each one of those equal-sized blocks is encrypted using the cipher algorithm and the key. The first block is combined with a random block of plaintext data to introduce randomness into the sequence. Every subsequent block after that, the plaintext version of it is XORed, or exclusive ORed, with the previous block's ciphertext before it's encrypted by the cipher key. XORing is a binary logic function. XORing is basically comparing two bits with each other. If the bits are different, it produces a 1. If they are the same, it produces a 0. It's used to kind of scramble data into an unreadable format using this predefined key. So the subsequent block is compared to the previous block, and it outputs the XOR operation, whatever that may be. Because of that XOR sequence, any single bit change in one of those blocks has a cascade effect, and every subsequent ciphertext block is different, which also helps with randomness and not being able to reverse it. I guess, long story short, AES 128 ECB does not do any of that, so it is not as random, and you can recognize patterns and kind of use those patterns to reverse it, and if the attackers did use that, it may not be a huge deal. It's still going to be a pain to reverse, but you're not completely SOL like you would be with most ransomware cases. Sysdig also noted that although the encryption key is randomly generated, it was not stored or transmitted to the attacker. And the Bitcoin address the AI agent linked was an example address used in public documentation, and it's likely the result of the AI agent reproducing it from training data or just public internet information. A major sign to researchers that this was AI done is because the AI was weirdly detailed in the comments of its generated code and, explained its logical reasoning and specific errors encountered when really a hacker would probably just write, retry. So, this attack was successful, though it did have some interesting issues, such as the whole encryption algorithm being probably pretty insecure, as well as the Bitcoin wallet address being a sample address. However, it is a concerning development and a message that agentic AI threat actors are here, and it's lowering the skill ceiling requiring for conducting real cyber attacks considerably. You don't need to be an expert on hacking anymore to do something like this, and that's kind of scary. There was not a human involved with this attack, which is just wild. And although AI is somewhat helping, somewhat causing issues with people's environments, it is also causing a lot of those same both benefits and downsides to threat actors, and it's going to be very interesting to see how something like this develops in the future. It's really going to be a lot of AI offense versus AI defense at this point, and humans are certainly going to still be needed for many things, but even AI enhancements would greatly reduce the skill ceiling for both fields, which has a lot of interesting opportunity, I think. Thank you to Bleeping Computer, Medium, and Security Week for information on this attack. And of course, thank you for tuning into this week's episode of Bite Size Cybercrime, and until next time, stay secure.